This summer, something remarkable is happening beneath our feet. Literally, Earth is spinning slightly faster than usual, trimming milliseconds off our days and captivating scientists and timekeepers around the world. On July 10, Earth completed its rotation 1.36 milliseconds faster than the standard 24 hours, making the shortest day of the 2025 so far. And this isn't a one-time quick. More abbreviated days are expected on July 2032 and August 5 predicted to be shorter by 1.34 and 1.25 milliseconds respectively, according to data compiled by TimeMandate.com from the U.S. Naval Observatory and International Earth Rotation and Reference System Service (IERS). Though these changes are minimal, imperceptible to daily life, their implications ripple far beyond the teaching of a second hand. From communication satellites to GPS navigation, from financial networks to internet server, the precise measuring of time is critical, and Earth's increasing pace poses a unique challenge to the global infrastructure that relies on atomic level timekeeping. So why the length of the day isn't always 24 hours? A day is technically the time it takes to complete a single rotation in its axis, 86 and 400 seconds or 24 hours. But in reality, this figure is just an average. It doesn't scale at a fixed scale. A variety of complex natural phenomena can cause subtle fluctuation, making some days slightly longer or shorter than others. The gravitational tug of war between Earth and the Moon is one of the major influences. The force caused by Moon stretches Earth's crust and slows down its spin over time. But there are other variables at play. Shifting atmospheric pattern, seasonal changes, ocean currents, earthquakes, and even movement within Earth's deep core all add their influence to the rotation. While these changes may seem insignificant, fractions are milliseconds, they are tracked with incredible precision by atomic clocks. Devices so accurate they won't use a second for millions of years. These clocks, which count the vibration of atoms to keep time, form the basis of Coordinated Universe Time (UTC), the standard by which all other timekeeping systems on Earth are synchronized. So back in 1972, Earth's rotation slowed enough that it was noticeable lagging behind atomic time. To reconcile the two, timekeepers attribute the leap second, an extra second occasionally added to UTC to bring the atomic time and solar time into alignment. Since then, 27 leap seconds have been added. Most of them occur in the 1970s and 1980s, a peak in which Earth rotation was slower. But in recent years, a curious trend has emerged. Earth has started spinning slightly faster. In fact, not a single leap second has been added since 2016. If trends continues, scientists say we might face an unprecedented scenario, the subtraction of the second from UTC, a so-called negative leap second. This has never happened before and presents a range of technical challenges or ignore the system that rely on precise, predictable timekeeping. So every year's fastest day on record. On July 5, 2004 now hold the record for the shortest day since the atomic clock was first used in 1960. On that day, Earth completed its rotation only 1.66 milliseconds faster than the standard 24 hours. It's a bit like watching the stock market, explains Duncan Egme, a professor emeritus of geophysics at the Scripps Institution of Oceanography. There's a long-term trend and short-term fluctuation. Its scheme has been gradually accelerating since around 1972, but it's not a small process. This growing speed is causing increasing interest among scientists, especially as predictions suggest a growing possibility that negative leap second may be required before 2025. So the potential risk of negative D is, while adding a second might seem harmless, subtracting one is a more delicate operation. Positive leap seconds have already caused problems in the past, even crashing computer systems and disrupting data logs. Some websites and platforms were temporarily locked offline when a leap second was added in 2012. A negative leap second has never been implemented, said Yuda Levine, a physicist at the National Institute of Standards and Technology, NIST. ST. And because it's never been done, we don't fully know how system will react. Many could be consistent from GPS and powered to telecommunication and banking, it turns on the precise uninterrupted time. The risk is not necessarily catastrophic, but as with the Y2K bug that alarmed the world in 1999, the uncertainty itself is enough to raise eyebrows. Even if only 1 millisecond is at stake, in today's high-frequency digital world, that can be enough to misalign financial trades, causing satellite miscalculation or interrupt synchronization after several. It's a small shift for the potential large customers. So why is the Earth spinning so fast? Several natural mechanisms contributed to this unexpected increase in rotational speed. One of the most immediate is the moon. The gravitational interaction between the moon and Earth's ocean create a tidal force that can either slow down or speed up the parallel spin. Where the moon is over the equator, tides act in a way that slightly slow Earth. At other altitudes, the effect can actually speed up rotation. There is also a seasonal effect during the summer months. Earth's atmosphere experiences changes, such as the northward or southward movement of a jet stream. Back up in atmospheric pressure, since the atmosphere is a part of Earth's system, changes in its momentum must be balanced by Earth itself. When the atmosphere slows down, the solid planet compensates by rotating faster. Initially, scientists have observed changes in its core. For roughly 5 decades, Earth's liquid core has been gradually slowing down, causing the solid outer layers of the planet to spin more because of the viscous. It's complicated as, said Lavie. Each element in the Earth system affects the whole. You can't change one part without the rest adjusted. Scientists forecast short-term variation in Earth rotation by analyzing the interaction factors. When Earth rotation speed up on one day, it's likely to do the same the next day, be it a short period correlation, but long-term prediction are far more uncertain. The IERS global body responsible for monitoring and adjusting UTC only issue forecast a year in advance. It becomes increasingly hard to predict over a longer period than, said Levin. Earth is just too dynamic. Despite this uncertainty, the current trend has raised the probability of negative leap second to roughly 40% between now and 2035, according to MBA. Climate change's role in this acceleration is, unexpected climate change is playing a role in all of this, but not in the way you might think. While global warming has triggered devastating effect on ecosystem and weather pattern, it may be acting as a brake on Earth's upset. It may be acting as a brake on Earth's accelerating spin. As glaciers and ice sheets in Greenland and the Antarctic melt, massive amount of water flow into the ocean. This redistribution of mass slow Earth rotation slightly, much like a spinning figure scatter extending their arms to reduce their speed. Agnew's 2023 studies published in Nature indicate that without this ongoing nature, you might only have caused the creation requiring a negative leak second. In that sense, climate change is unintentionally denying this need for this adjustment. NASA data supports this view. Since 1993, Mercator compolar ice sheets has been contributed to nearly a steady global sea level. This shift is in mass not only alter the speed of rotation but also affect the Earth's axis of rotation. The Earth is in perfect balance. Spinning top, explained Benedict Soldier and Searcher at ETH Zurich. When mass move around, whenever through melting ice or seismic activity, it shifts the distribution of weight, which in return shifts how and where the Earth rotates. The rotational behavior of our planet has always yielded an story of causes in flux tidal movements, atmospheric winds, underground lava currents, and now melting ice caps. What's new is how deeply human systems have become intertwined with cosmic rock. A few milliseconds and there might not affect your wish to watch, but in a world driven by split-second trimming, instant communication, and discipline precision, this micro adjustment take an outside signature. So what comes next? The decision to add or subtract the leak second like IERS, but it also guided by recommendation from scientific bodies and the global consensus. In 2022, General Conference on Weight and Measure voted to eliminate leap second altogether by 2035, citing the increasing difficulty in implementing them separately across complex networks. If negative leap second becomes necessary before then, it will be historic moment, one that tests the adaptability of the technology and our understanding of the planetary system.